Hey everyone, and welcome to today's Explainer. So today we're going to unpack the incredible and honestly, often completely invisible journey of clouds. We look at them every single day, right? We plan our weekends around them, we complain when they block the sun, but rarely do we actually stop to consider the truly epic voyage they take. We're going to trace that exact path, from their absolute birth down here on Earth, all the way to their final towering destinations high up in our atmosphere. Seriously, think about it for a quick second. Where do these mysterious floating shapes actually come from? And once they drift away, where do they just, vanish to? They seem to pop up completely out of thin air, almost like atmospheric magic tricks. But there is an absolutely fascinating, ancient, and highly complex science happening right above our heads, literally every single moment of the day. Okay, let's map out our skyward journey for today. First up, the birth of clouds, then defying gravity. After that, we'll look at the types of clouds. Then we'll answer the big question, where do clouds go? And finally, we'll wrap things up with the endless water cycle. Let's dive in. Part 1, the birth of clouds. So this whole journey actually kicks off right beneath our feet. The sun beats down, heating up the immense volumes of water in our oceans, rushing rivers, calm lakes, and even the damp soil right in your backyard. This heat triggers evaporation. Now, you probably already know the basic mechanics here. It's liquid water transforming into an invisible gas called water vapor. But I really want you to consider the sheer, staggering scale of what's happening. At any given second, millions upon millions of gallons of water are silently turning into gas all around the globe. And since warm air is lighter than cool air, those immense oceans of vapor are rising up into the atmosphere right now, completely unseen by the human eye. As that invisible air rises higher and higher, the atmospheric pressure drops. The air expands and, crucially, it cools down. And since cool air just can't hold anywhere near as much moisture as warm air, condensation kicks in. That invisible vapor begins turning back into tiny liquid droplets or ice crystals. But here's the really fascinating secret ingredient for cloud formation. These droplets desperately need a foundation. They need something to physically hold on to in the vast emptiness of the sky. So what do? They cling to microscopic hitchhikers already floating in the air. We're talking specks of dust from a desert, sea salt sprayed from crashing ocean waves, or even ash from a distant fire. Without those tiny, almost imperceptible particles, the sky above us would look very, very different. Moving on to part 2, defying gravity. Get this, a single average-sized cumulus cloud can weigh hundreds or even thousands of tons. Just let that sink in for a moment. That's the equivalent weight of a massive herd of like 100 fully grown elephants just hovering directly over your head on a random Tuesday afternoon. It's wild. We tend to picture clouds as weightless, fluffy cotton candy that you could just wave your hand right through. But in reality, we're looking at massive, impossibly heavy oceans of suspended water. So the obvious glaring question here is, why on earth doesn't it all just come crashing down on us at once? So why doesn't that elephant-sized weight crush us? Well, the secret lies in the microscopic, almost incomprehensible size of the individual droplets. They are so incredibly tiny that they distribute that massive weight over a vast, vast area of the sky. Think of it kind of like a single feather. If you blow a feather into the air, it doesn't just plummet like a stone, right? The rising air currents easily support it. A cloud is essentially trillions upon trillions of these microscopic feathers riding powerful, invisible thermal updrafts. These immense columns of rising air are constantly pushing back against gravity, keeping the heavy giants afloat. Part 3, types of clouds. Now, the specific conditions of that rising air completely dictate the architecture of the sky. We all recognize cumulus clouds, right? Those pleasant, fluffy white structures drifting by on a perfect sunny afternoon, built by gentle, steady updrafts. But if you look higher, you'll find cirrus clouds, thin, icy wisps living miles above us, painting a fair weather sky. Then, when the atmosphere settles into a wide, stable block, we get stratus clouds, you know the ones, those flat, gray, featureless blankets that bring us that steady, unyielding drizzle. And finally, there are the undisputed kings of the sky, the cumulonimbus. These are towering, violent, churning monsters where rapid, intense updrafts spawn severe thunderstorms, spectacular lightning shows, destructive hail, and even tornadoes. The sky is essentially a real-time museum of atmospheric physics. Part 4, where do clouds go? The thing you have to realize is that clouds are the ultimate nomads. They don't just hover over the exact spot they were born, politely waiting to rain. No, they're actively hijacked by high-altitude winds and powerful jet streams, traveling across entire continents and vast oceans at breakneck speeds. And by tracking these massive moving cloud systems with global satellites, meteorologists aren't just looking at pretty swirling pictures on a screen. They're watching a real-time, highly complex fluid dynamics map. They track these immense systems minute by minute to predict exactly what kind of atmospheric energy is going to hit us down on the ground tomorrow. But, every cloud's journey eventually comes to an end, and it usually happens in one of two distinct ways. Often, they just simply disappear. If a cloud drifts into a region of warmer, drier air, those tiny, perfectly suspended droplets rapidly evaporate right back into an invisible gas. They just vanish without a trace, almost as if they were never there. But if the updrafts are strong and the moisture is plentiful, droplets violently collide, merge, and grow. Eventually, they become way too heavy for even the strongest wind to support. Gravity, finally, inevitably wins, and the cloud falls apart, sending its payload down to us as precipitation. So whether that's rain, snow, sleet, or heavy hail, what goes up must eventually come down. Part 5. The Endless Water Cycle. Zooming out from the life of a single cloud, this entire process is part of a staggering planetary engine that has been running uninterrupted for billions of years. Step 1. The sun continuously heats the Earth's surface. Step 2. That triggers evaporation. Step 3. That invisible vapor rises. Step 4. It expands, cools, and condenses into clouds. Step 5. Those clouds are carried by global winds before finally producing precipitation. And step 6. The water returns to Earth, and the cycle repeats all over again. This means our planet is constantly recycling the exact same water in an eternal loop. So that water pouring from a summer storm today, it might have once been trapped in a prehistoric glacier or rushing down an ancient, unmapped river. It connects our deep oceans, our highest mountains, our dense forests, and absolutely every living thing. To truly appreciate how dynamic and powerful this cycle is, just consider the sheer speed involved. Thanks to incredibly violent upper-level winds circling the globe, some of these massive cloud systems aren't just lazily drifting. They are literally racing across the sky at 150 kilometers per hour. That is literal highway speed. Just imagine thousands of tons of water flying right above our heads, faster than most cars are legally allowed to drive. It's crazy. And the vertical scale is just as mind-bending. A large thunderstorm cloud, you remember those cumulonimbus monsters we talked about, can tower 15 kilometers deep into the atmosphere. To put that into perspective, that is nearly twice the height of Mount Everest. Just think about that for a second. An entire towering mountain range made completely of turbulent water and ice, just floating up there in the sky, crackling with electrical energy. Ultimately, these vast collections of tiny droplets are the unsung heroes of our entire environment. Not only do they continuously distribute the lifeblood of water across the globe, but they also act as Earth's critical atmospheric thermostat. They reflect incoming, scorching sunlight away during the day, and they trap outgoing, vital heat at night. Without clouds doing this invisible heavy lifting for us, our climate would swing wildly between brutal, unlivable daytime heat and freezing, uninhabitable nights. So, the next time you look up, ask yourself, which part of this ancient, invisible journey are you actually witnessing? Are you watching a brand new cloud being born from invisible vapor rising from the soil? Or are you watching thousands of tons of ancient water hovering on the edge of gravity, about to fall back to Earth to start the cycle all over again? It definitely changes how you see the sky above you, doesn't it? Thanks for joining me for this explainer. Keep looking up and keep learning.